We'd like to take a quick second to thank our sponsors, and without them, we're not able to put on these JUG events. So we'd like to thank our sponsors again for doing that. And also, last week was the Java 17 release. So if you did not hear about it, Java 17 was released last week. It is the now current LTS or long-term release instead of the intermediate releases that have been going on. And there's a big push around Java 17 and people getting upgraded to it and upgrading their code bases to it. So if you haven't done so already, you should go check it out and see what they've included in the new Java 17 builds. There hasn't been a lot of new features that have been included in Java 17. There is some stuff around seal classes and around expressions for switch statements and things like that. But a lot of the cooler features in Java have come in previous releases. Like, for example, records came in 14, but that, again, was an intermediate release. So in Java 17, we have all those things since the last LTS release, which was Java 11, now included in this LTS release. So go check it out and tell us what you think in the YouTube channel if you're thinking of upgrading or if you've at least looked at it or thought about it. Okay. All right. So also, we are going to go and hang out outside at the Taco Mac down the road from here. If you'd like to join us for some food and some beverages after the meetup is concluded. And without further ado, I'd like to bring Glenn on to start talking about application modernization, migrating monolith apps to the cloud using Spring.
Dude, what are these people doing in my living room? And do I have to wear this?
I don't think so.
You don't think I need earphones? Or there's people out here.
Yeah.
This is weird. So hey folks, I am Glenn Renfro. This is my first time talking to people live in 18 months. So if you hear jitters and jumps around, it's because I haven't talked to y'all in so long. So it is so good to be here. Off of the kind of doing the virtual discussions, but those folks that are on virtually, thank y'all for coming. Y'all are awesome. So we welcome you here to AJUG. But kick off a little bit, we're going to be talking about application modernization. We're going to talk about migrating your monolith apps to the cloud using Spring. Notice it's kind of got this kind of brown paper look to it, and that's because I have a lot of friends of mine that have gotten into the gaming world, and both board games and RPGs, and well, guess what? They have pulled me into it. And with that being said, this is not going to be just a regular talk. It's going to be a bit of a quest. So let's kick back and enjoy the quest. But as beginning with any quest, we have to have our attorneys along, right? So with our attorneys being along, feel free to read this, or you can check it on my slide deck afterward and enjoy all that micro print right there. So, first thing, what is a monolith? Is a monolith something that appears magically in a Utah desert and then allows things to evolve? Is it like my monolith action figure I have here that so far I have it set next to some Lego figures? So far they have not evolved, but I have certainly still trying and waiting for one day for them to evolve from this little monolith action figure. Okay, enough of the humor. Bad humor as it is. With that, what we're going to be talking about is what is a monolith. A monolith is something that, is just basically an all-encompassing application. There's nothing wrong with them. But some of the monoliths we've had have been out there for many, many years. And so it's time to update them, and we want to, we want to migrate these to the cloud. But as we migrate from the cloud, we want to be able to update them and give them the new features, maybe add the technologies, not just do a shift over, but actually do an upgrade. May even change these monoliths into microservices. It's whatever you want. But with that being said, we also have a lot of mainframes out there. Surely mainframes will be gone by now. But the mainframes that are still out there have batch applications, online applications, but we as well want to migrate these apps to a cloud. So in this talk, we're going to talk about some of the patterns that you can implement in order to move these apps off of the mainframe, or move our Monolith apps or features off of our Monolith apps into the cloud. And we're going to kind of discuss a couple, again, major paths, but then we're going to take one of those paths and we're going to kind of follow it and see if we can get some of this data off of this, from the mainframe or from the Monolith off. Well, who am I? My name is Glenn Renfro. I am one of the developers at VMware. I work primarily on the Spring Suite. I work on Spring Cloud Dataflow, Spring Cloud Tasks, Spring Batch, and kind of anywhere else they need me. The other thing that I do is I'm also on the board of directors of AJUG and DevNex, which means I'm also on DevNexus. DevNexus, we're shooting for April 2022. I'm really excited about that. If you want to reach out to me, feel free to reach out to me at CPPWFS on Twitter. So, well, with anything, we have an agenda. So, of course, our monoliths and our mainframes surely should be gone by now, right? We always update them. We always get rid of those things, right, with the right time. And then, of course, that may not always be true. I have one of my old monoliths. This has been out there for 13 years. They do updates and security updates on it, but the code I wrote 13 years ago is still out there. Mainframe apps, they've been out there even longer. So these apps and services are still out there, still being used. So we're going to discuss, again, how can we maybe, when it's time to move to cloud, how we can pull those out. Again, the strategies. One of the strategies we're going to talk about is streaming info out of those mainframe and of the monolith onto our cloud platform. How can we do that? So we're going to discuss that. Since, of course, I work on the batch side of things, we're going to certainly talk about migrating some batch apps. But also we're going to talk about that now that we've moved this data off from the monolith into a place that we can take action on it. We're not only going to take action on it with the apps that we want to migrate, but new apps want to be able to take advantage of it, correct? So let's see what we can do with that. So we're going to talk about how we can access that data. And then as we move these apps off and create these new services, we want to keep the footprint small. We don't want this to be a large application, right? Or take up a lot of memory. So how can we keep these things small? So we'll talk about that as well. Well, before we go in, I have to talk about the pain point. Why would we want to move apps to the cloud? Why even migrate at all? So I did a mainframe migration many eons ago. I was hired onto a company. They were already working on their app that was going to take the place of the mainframe applications. And this is back when we only did monoliths. And the goal is that when I got hired on was to help them kind of finish it out, right? So they planned on trying to go live with it in the next 3 to 4 months. And so I started working there, and within about just under a month, the mainframe went down. And unfortunately, they didn't have a backup. And I'm going to say something that's going to make y'all shudder, because it still makes me a little scary, queasy here. It was down for 2 days. They called in technicians. They called in the mainframe developers were working on it. They couldn't figure it out. But one person that had been working on it and just knew the system inside and out had just left. Well, thankfully, they were able to call him back. He came back in and was able to resolve the problem in like 2 to 3 hours. So when we look at why do we want to move off the mainframe, it's many reasons. This company wanted to move for the classic reasons: to reduce cost, to increase the pool of available developers to work on it, have ability to have additional and new features, right? And also plug it into a framework that was going to be going forward. But more critically, the one thing is that we want to make sure is that as we migrate, we want to document and identify and be able to document what changes and what we're doing as we migrate off, so we can have a great documentation plan, but also have those features and have the developers, a wider range of developers can pick up when something goes wrong. So, what are the 2 major ways of migrating data off? Well, one, of course, is the big bang. One is that we say we provide our environment, we get it set up where we're going to be moving to, and then in one fell swoop, we're going to move everything off from the existing monolith into the cloud infrastructure, just get it done, right? Well, the issue with that is that a lot of people kind of shy away from is there's a great chance at failure, meaning you're going to do one mass move. The chance of failure increases substantially. So how do we handle that? And so typically what people do is utilize something called what we call a strangler or strangulation pattern. And that is, we see that we have our existing system on the left, and then on the right we have our new cloud platform that we're going to be migrating to. With that, what we're going to talk about is that we may start creating new services in the cloud platform, as we see already, but the majority of these other applications on the mainframe, we want to start moving them over. So what happens is you begin to slowly but surely move these applications off of the mainframe onto your cloud platform, thus reducing the number of services and the number of hits that are on the mainframe, or reduce the number of services and hits that you're having on the existing monolith, and implement it into what? The new cloud platform that you're utilizing. So, the thing to remember is that even when we talk about these big bulk moves, whether it's big bang or we're going to use the strangulation pattern, we have to remember there's going to be several paths that we can take, right? So here is our company island. Our company island has many paths in it for migrating our apps alpha, if you will, mainframeville, right? But we also have that data is in existing data mountains, right? So part of our quest is what path should we take in order to get the data out of the mainframeville or the existing data mountains? Well, the name of our quest is called the Quest of a Cell Phone. And basically what we want to do is we have an existing cell phone company that majority of their stuff is on the mainframe. And what we want to be able to do is to be able to take and track the user data as well as the data usage, and we want to begin a strangular pattern. We want to take that data off of the mainframe, get a feed off of the mainframe, or if you will, the feed off of the monolith, and send that data to a location that we can take and utilize our batch jobs to be able to retrieve that data from that data, if we will, the data that's been migrated off, but also allow and provide the services that can access that data, so as we create new services, they can access this, if you will, this API and be able to take advantage of that data that we're coming off of the existing mainframe. So, path one is we want to take and get the data off out of our existing data mountains and into our data lake. And we've named this Spring Cloud Stream. Okay, yeah, all right, I know. There's going to be so many puns that you're going to be like, Glenn, cut it out, too many. But I'm sorry, I'm a very punny guy. So we're going to have a bunch of these on our company island. The next is we're going to take a path to Batchington. And in Batchington, what we're going to do is we're going to get this user data and this plan data, and we're going to create and generate some flat files. One's going to be a bill run file, and the other's going to be a customer report file. And what we're going to do is we're going to plant those flat files into the flat file forest. Yet more puns. We will continue down this punny path, I guarantee you. Please don't hang up off your laptops. People, don't leave. Please stay. I promise. There's fewer after this. The other is, how can we provide a good API for people to be able to access this data, right? Such that they can ask for exactly what they want. So we're going to be visiting GraphQL Town, and we're going to provide a show of a service of what that looks like. So, chapter one, we're going to be following the stream. So what we're looking at is we have an existing system. It has data on it. So part of the thing that we're going to be looking at is, since we have all this data on it, we need to get it into the cloud platform. Now, when we say cloud platform, Glenn, what do you mean? Well, that could be just your own server still. It could be a hybrid of your servers with a cloud platform. It could be all into one platform or cloud platform, whether it's AWS or Azure, take your pick, right? But it also could be multiple cloud platforms. So we want to be able to get this data off the existing monolith and be able to push this into our cloud platform or our cloud platform infrastructure that we're going to be providing. So going back to the map, stage 1, let's get that data out of the existing data mountains into the data lake through a Spring Cloud Stream. So if you haven't figured it out, the two tools we're going to be using is Spring Cloud Stream, and then we're going to use Spring Cloud Data Flow for the orchestration. Now, what we're going to be showing you is how to create applications that are going to be able to pull this data out of the mainframe, and we're going to show you how a Spring Cloud Stream can simplify your, the writing of your code to be able to create this code, to be able to take that data, transform, filter that data, and then insert it into another database. And then we're going to use Dataflow just to show you how this looks. And again, it's sort of an optional piece, but it is a way that we can visualize the creation of these streams. So, part of the, as you saw advertised, we're going to talk a little bit about Debezium. So what is Debezium? Well, let's keep this in mind. Let's talk about this a little bit. So, one of the things we need to do is that this monolith is going to be hitting off of a data store, right? And in this data store, there's going to be data just constantly being updated. So what we want to be able to do is get a live feed of that data and capture the events that's occurring in this database for specific tables and be able to get that data and be able to change those events and be able to insert those events and put them into somewhere that can take these events and consume them. Debezium does that. In this style of patterns called CDC, or change data capture, and that's exactly what Debezium does. It's going to monitor our database log, and as events occur to the database log, it's going to capture those and put those events into a Kafka topic. So we're going to have, that's the first part of our stream. That's going to be our source, right? The source of our stream. Then we're going to have another application we're going to have that's going to take that data and it's going to filter out all the events we don't care about. Even though we're going to set it up to where we're just going to watch, like, again, the usage table, the plan table, the user table, we're going to get other events that we don't care about. So we want to filter those out. The other thing we want to do is transform that data into something that's usable downstream. The third app we're going to have is a target database app. This app is going to take the filtered, transformed data and then insert that into the data store on our cloud platform so that we can take advantage of it. All this is going to be coming through Kafka topics. So our goal will be to be able to retrieve this data, filter it, transform it, and then have another app that's going to insert the data into our new database. And I wouldn't be a Spring developer if I didn't say that it's going to be written using Spring Boot. Sorry. Got to have it. It's actually cool stuff. I like it. And then you're saying, well, Glenn, that's pretty cool. I like that. But now you're saying I've got to sit there and write code to hook these apps that I've got to write and write the code to hook it into a Kafka topic. What if I said, you don't have to write the code to hook it into the Kafka topics? What if you could do that through a set of properties, and the only code you have to write is the function itself? The function that does that transforming, the function that does the filtering. What if we could do that and not have to worry about writing any of that code to integrate into Kafka? Well, the project we're going to be using is Spring Cloud Stream, and that's going to be able to reduce how much time it takes for us to write the code. The other thing to remember is this. I only have to really write two applications. We're going to have an application called Spring Cloud Stream, it's a Debezium application, and it has already been written for us. It is in a project called Spring Cloud Stream Applications, and it is available up on GitHub. You can pull the project down, you can build that project, and you'll have a Debezium source available to you that you can configure whatever way you want through properties, and it will hook in and to the database you point it to and pull that data out and then push these events to a Kafka topic. The other two apps we're going to write, and I think it is time that we demo it. Now, there's good news and there's bad news here. The first thing to remember is I demo code horribly. And when I say horribly, I mean exactly that. So what we're going to do is we're going to go in and we're going to go to our DBZ transform, and I've already written this code. Now, if you're interested in seeing the code, the good news is at the end of the presentation, I'm going to have a link to my GitHub repository. All these things are available there. So what we're going to do is take a look at how Spring Cloud Stream can allow me to hook into the Kafka easily and smoothly. Well, the first thing we're going to do is we need our dependencies, right? I'm going to kind of make this a little bigger. Sorry about that, didn't do that already. And there's a couple things that we're going to need. The first thing that we're going to realize that this is just a Maven POM. Yep, I still use Maven. There's nothing wrong with it. I love it. And in this case, we see that we're going to use it. We're still using our Spring Boot Starter. We have our Boot Starter Actuator. We have our Spring Boot Starter Web, yay. But the thing that we're really interested in is these little bits right here. I want Spring Cloud Stream. Sorry, I want my Spring Boot app. Oop, let me go down a little bit. Included too much there. I want to include Spring Cloud Stream. And then I want Spring Cloud Stream to say, well, what binder do I want? Do I want Kafka? Do I want AMQP? Do I want Google PubSub? Do I want Kinesis? What do I want? Well, I can specify the binder that I want. In this case, it's Kafka. And so the goal is that now I can tell Spring Cloud Stream, I want you to be ready to accept properties, and I want you to hook us directly into a Kafka topic. Now, there's a little hint I'm going to show you here. There's another dependency you usually don't see, and it's called Spring Cloud Function. And notice the name is filter function. Remember that. We're going to come back to that in a second. So, you say, Glenn, configuration, what does that mean? Well, the first thing I want to do is I want to declare my function that I want to use. I want to have a transform function. But notice that I have something here called filter function with a pipe. What is that? That is, I can compose a function. So I can have composable functions here that can take the output of the function transform and send that out to a filter function. And you're like, okay, cool. So you want to transform everything you transform, you then want to go in and filter it. All right, what does a transform function look like? Well, if we go in and see how Glenn is such a lazy developer, we can go in and take a look right here. We can see that this is a DBZ transform application. Here's my main. And you see I have exactly one bean here. And we can scroll down and see I have no other beans. No, nothing behind the hands. Look at that. And, and in that case, we can have our bean. And we see that in here, that this is where I do my transform, right? It's a regular function. That's it. And then what we see is that down here, you see I have some methods that will translate the plan, translate the user, translate the call usage, and translate the data usage. And then I have another method that just says, it's basically a dummy method, doesn't do anything, and it says translate others. But the two things I want you to notice here is that not only is it a function, but notice that I have is usage here. Meaning I have a specific goal in this stream is I'm going to track usage data. And that usage data, in this case, is the plans, users, call usage, and data usage. So I'm defaulting that to true. But if I receive data and I don't know what that data is, meaning if I get the table name and I don't know if it's not a table name or something I can directly work with, I want to set the is usage defaults, meaning I don't know what it is, I don't care about it, let's not use it. That becomes critical because at the end of the method, I could pass back just a string. I could just say, I translated it, here's the string, boom, oh, here's a null, go, there's nothing there, just null. But in this case, I want to do a little something here. And what I want to do is I want to put that usage, that is usage, I want to put it in the message header. So my transform is providing a lot of value here. One, it's transforming the message into something that I'm getting from Debezium, into something my downstream apps can use. And then I'm able to put in header information that gives us additional information that we can look at to be able to apply to messages that we send after the transformer. So the thing that we see is that we have our transform, and that's all it is. Again, this is a transform function. But then we see we have a filter function, but you said, Glenn, you said there was only one bean there. And I'm like, absolutely. Remember when I said we were showing you in the POM file where I had that filter function included? Yes, Spring Cloud Application also provides you functions that you can pull in, because Spring Cloud Stream also uses Spring Cloud Function so that I can write functions and put them in jars and put them as dependencies and then use them directly in the stream. So in this case, you can see that I wrote the transform. I'm using a filter function that is available from the Spring Cloud string functions. And then all I have to do is, you can see I have filter function expression. And then I say when headers usage equals true, let the message true. But everything else I want to just discard. So what does this look like? Well, what I'm going to do is, I know this is hard to see at the bottom. I'm going to go ahead and maven clean install. Yes, I said install. Install this to my local Maven repository, because I want to use now Spring Cloud Dataflow to be able to compose my stream. I could certainly compose this stream if I wanted to, and just run the apps and then set the properties for connecting and all that good stuff at the right time. But in this case, I want to use Spring Cloud Dataflow to be able to compose this together. So what we're going to do is we're going to go to streams, and we're going to create our stream. So in this case, I didn't tell Dataflow where to find that my transform. So let me tell Dataflow where to find that transform. So I'm going to register an app, and we're going to call it DBZ transform. Amazing. It looks like I may have keyed this in once before in my life. I practice. I'm sorry. It happens. In this case, it's going to be a processor. I can create in Spring Cloud Dataflow. I can have a source like our Debezium. I can have a processor like our DBZ transform. And I can have a sink like what we have that's going to update our database. But I can also have tasks. Remember that. We'll be talking about tasks in a little bit. But we, right now, are going to look at processors. So I need to tell Dataflow where it can use that processor that we created, the DBZ transform. And it is in my local Maven repository, io.spring. And it is Spring DBZ transform was the name. And it's a snapshot. Yes, we are dealing with snapshots. Oops, what did I mess up? Okay, what did I mess up here? That's the reason why. Let's see. DBZ transform, snapshot. Okay, what did I mess up here? Oh, I forgot to delete the last registration I did. Whoops. So I've already have it registered. I'm sorry. I should have cleaned out better, but we can see I have a DBZ transform, and we can see that it is the Maven repository. That's the reason you always read your error messages. They're kind of valuable, right? So with that being said, let's go on. So the next thing I want to do is I'm going to create my stream. I'm going to drop a hint. I've already registered the CDC Debezium here, which is, again, for our source. Here was DBZ transform. That was the thing I was supposed to register and didn't. And then I want to apply my sync. I've already registered the DB updater right here. And there we go. I've just created a stream. Now what I'm doing is I'm composing my stream, and now we will call that a stream definition. Now, at this time, I can create this stream, and then in a moment tell Spring Cloud Dataflow I want to deploy the stream. But you're saying, well, Glenn, hold on a second. How does it know what databases to hook into? Remember, Debezium needs to hook into a database to monitor, and your database updater needs to know what other database to update. So through Spring Cloud Dataflow, I can apply these properties at string definition time or stream definition time like I'm doing right now, or I can do it at the time that I deploy. And if you remember at the beginning of our conversation, I said that what, if we remember? I am a horrible at demos, so I copy and paste like crazy. In this case, I'm going to go ahead and apply the connection strings at definition time. Normally you wouldn't do that, but I'm, again, lazy. I've already pre-named it CDC updater. We're going to create that stream, so now I have a stream definition. So now I'm going to tell Spring Cloud Dataflow to go ahead and deploy it. And we see that it's got all that good deployment stuff ready from where I declared it in stream. But then again, I could have waited to here, and you could have watched me enter in and mess up all the deployment properties. So what we're going to do now is we're going to tell Spring Cloud Dataflow to deploy this. Spring Cloud Dataflow can deploy to, in this case, I'm deploying to my local machine. It can deploy to Tanzu Application Service or Kubernetes. It's up to you where you want to be. It does that for you. So it could be Docker, and when it deploys to Docker, it handles all the pod stuff for you on Kubernetes. So it's really cool when it can do that. But in this case, I'm just running it locally. And we can see that it is now deployed. I was supposed to show you this up front, that all my tables were empty, and I didn't, but I can hit a refresh here and show you that we have a little bit of data there, data usage, a little call usage, and we still have a little bit of, we have like one plan, and we have some users with about 3 users in it. So what we've just seen is that through a stream, I can take in data from an existing database that's running on a different system, monitor it, capture that data, filter the data, transform that data into something useful, and then upload it into another cloud platform's database so that we can take advantage of that data. So now that we have that data in the database, we're going to go back and we're going to start taking advantage of it. So let's go back to our presentation here. And we'll play from current slide. And we should be magically appearing now. All right, so one other thing I wanted to bring up about when you're dealing with streams. So who remembers reading the Enterprise Integration Pattern? It was a big, thick black book. Everybody raised their hands except for the sound guy, and he's looking at me like, what in the hell are you talking about? And so with that being said, what were some of the things that you could learn how you could route the data? It was what? You could tap data, you could do routers, you could do scatter, gather, you could do all these various patterns that are available to you. When you're dealing with streams, you can do the same thing, right? So Spring Cloud Stream allows you to be able to create streams this way. Dataflow allows you to compose these streams in this way, and also handles the updating and the rolling back of various elements in your stream. So if you just want to deploy your streams directly, Spring Cloud, writing a Spring Boot app, Spring Cloud Stream, utilizing to hook into your topics, go for it. It works beautifully. If you want something to manage your streams and the composition of your streams, use Dataflow to help you with that. And this example shows you that we could see that I had my original line of where I was sending the data, getting the data from Debezium, sending it to a transform, and then sending it onto the target DB. In this case, we can tap off and get a copy of that data and send it on a whole new stream. And you can tap at any location because a tap, by its very definition, gets a copy of the data without affecting the original flow, and then sends it to a secondary flow. So the goal is that you can think of streams as not just one individual isolated item, but many streams. So, chapter 2 of our quest. Yes, and the puns continue. We're going to Batchington. And what are we going to do with Batchington? Remember, so now that data is in our data lake, if you will, what we're going to be doing now is going in and creating, we want to be able to extract that data and create a build run file. And then what we're going to be able to also do is take that data in that build run file and then create a customer build run. And we're going to plant these wonderful things into the flat file forest. What tools we're going to use? You're going to say, Glenn, I'm surprised. You working on Spring Batch would actually talk about Spring Batch. Well, guess what? We'll talk about Spring Batch. So if you haven't know what Spring Batch is basically a tool suite that allows you to remove a lot of the boilerplate code it takes to write a batch application. It provides you a series of readers and writers that you can configure to be able to read data from one source and write them out to another. It also has this concept of steps, so I can have multiple steps in my batch file, each step having a reader, a writer, and a processor. And the only code that you're really writing other than configuring your readers and writers is writing that processor code. Spring Batch also provides you the ability to restart your applications and also handles the transactions for you. So that's what's really cool about Spring Batch. But the other thing we remember is that since we're running a cloud platform, we want our batch applications to be good citizens in the cloud platform, meaning if I'm running a Kubernetes instance, I could be launching jobs in different namespaces, different clusters. If I'm on cloud platforms, I could be running them in different cloud platforms. How can I keep track of how my applications are running and where they're running and whether they're successful or not from a single location? Spring Cloud Task offers these features for you by allowing your apps when they start to be able to report their status to exactly one location, so you have only one place to check. No matter what cluster, no matter what namespace, no matter what platform you're running on, it offers these features for you. It also offers your features such that you can, if you have, like for example, a lot of batch apps are scheduled. So if I'm scheduling my applications, I want to make sure that only one instance of this particular application is running at a time. Spring Cloud Task offers features where you can establish properties that go in and say, hey, this one's already running somewhere else, I'm going to terminate. But it's up to you, and Spring Cloud Task can offer those properties for you, as well as a lot of other things. And again, we're going to also include Spring Cloud Data Flow. In this case, we're going to use Spring Cloud Data Flow to be able to create a workflow. And what is that workflow going to look like, Glenn? Well, I'm going to give y'all nightmares. This is what I used to have to write in college from time to time, and we called it JCL. If you don't know what it is, good. Don't ever learn it. But if you already know what it is, I'm sorry I brought back nightmares. It does exist out there. But what we want to look at is particularly in this, since we did mention mainframes, and the reason I chose this was to show that batch jobs typically don't live in isolation. They typically live where one is run, it does something, and its output gets cascaded to something else. And again, you could be thinking of something like Argo, because like with Argo, it does the same thing. It handles workflows. It runs a batch job, or runs a batch job. Then after that, you can create parallel stuff, parallel batch jobs, conditionals, and all that. So we want to be able to support that type of features using some Spring tooling here, and I want to show you what that looks like. With that being said, what we're going to be doing is we're going to be generating our build file. It's going to read data from our database. It's going to write it out to a flat file, and then the generate customer report is going to read that data from that flat file and then create yet another flat file. We're going to be using Spring Boot to do this. And like I said before, we're going to be using Spring Batch to so we don't have to write all this templated code or write all this kind of boilerplate code. We can take and utilize its builders and its workflow to manage this for us. And again, since we're running this in a cloud platform, we don't know where stuff's going to be. We need some of the special features to let our applications be good citizens in the cloud platform. We're also going to include Spring Cloud Task. So what we're going to be writing today is what's going to be called a single-step batch job. We're going to have two single-step batch jobs. The first one is the build run. And what we're going to use is we're going to use one of Spring Batch's readers. In this case, we're going to use this JDBC cursor reader. Spring Batch offers many different types of readers, from everything from the JDBC reader, Mongo, Kafka, AMQP, flat file, the list goes on and on. You can take a look at those. The code that I'm going to write is going to do some calculations for us to calculate what the what the bill is expected for each user, and that's going to be typical Java code. And then we're going to take and use a builder to create our writer. And again, Spring Batch has all these writers. In this case, we're just going to use the flat file writer. But like in that list I had before, the Mongos, the Kafkas, the AMQPs, the flat files, all that, it provides those. You can take a look. So in this goal is, if from a single step, I want to have a reader, a processor, and a writer. So what we're going to do is, after we write, and we're going to have a quick demo of what it looks like to create a batch file, is we're going to generate a build file. And what that's going to happen is that batch job is going to run. After it runs, it's going to, we're going to use Spring Cloud Data Flow and something called Compose Task Runner, which is its workflow engine. And once that batch job is complete, it's going to in turn call the customer report, and it's going to run that one as well. Keeping in mind that you say, well, Glenn, we really don't use Spring Batch, that's fine. When we talk about batch files or batch running, we also have to understand they're what? Ephemeral. They start, they do something, they terminate. This could be just a regular boot app that just does exactly that. They don't have to use Spring Batch. But if you want to, and you can certainly use Spring Cloud Task, again, to track the life cycle of your application, as well as use Spring Cloud Data Flow for the workflow engine. So with that, I think it's demo time. And what we're going to do is we're going to see a little bit of a black screen right there. And we're going to go back to IntelliJ. And we're going to go look at our build run demo. And there we go. And with the build run demo, we're going to take a look at a couple of things. First off, what we're going to realize is that we have our build run configuration. And we can't really zoom in over here, but we see we have our build run configuration. We have our build run properties. We have something called a build entity. This is how we're going to exchange data between the various elements of our single step, between the reader, the processor, and the writer. The build entry is just a regular POJO. You see it's got like plan ID, plan name, call price, call usage, all that good stuff. And we see our build run application, nothing special here. Again, it is nothing more than just a regular Spring Boot application. All the magic is in the what? The build run configuration. And in this build run configuration, we can see that we have enable batch processing. So we're saying, hey, we're going to kick off, we're going to have our batch processing. This is going to be what we're going to be utilizing here. And also, we're going to use @enable task. And you're saying, Glenn, what's the POM file was? It seemed pretty important earlier. And I'm like, okay, I'll show you. In this case, we're going to zoom it. Wow, come on, IntelliJ, be nice. It's not being nice here at all. Here we go. In this case, we can see that we've got our Spring Boot starter batch, JDBC, and we also include our task. You see I have an H2 for the test DB, and I'm using MariaDB to be able to hook into the new data, the data lake that we've created. We're going to go to build run configuration. We've seen that we had our enable task and enable batch processing. And we have the first two things. Well, I'm going to create my job, right? And so we have our job here. And it's going to contain exactly one step. Remember, a job can have many steps. You can run these steps in parallel. You can do conditionals, all that good stuff. If you want to be able to run those all within one batch job, batch supports that. But then you can see that we go look at our one step that we're going to be using today. And we see that we have our reader, our processor, and our writer. So where do we get this reader, processor, and writer? Well, let's start off with a writer. And we can see with the writer, what do we have here? We have our flat file item writer builder. And I just set in my resource. Where do I find my output file, which is a properties file here. And we can see that zooming in just a little bit there, that I'm just looking at a build run result. Or sorry, I'm writing out, not pulling in, but writing out to build run result in my temp directory. We see that I want encoded UTF-16. You see that should delete the file if there's nothing there. True. If I go on a pin to it. All this good stuff, all that is supported through the writer. But what's really interesting is if you remember when we looked at the build entry, it's got all this data that's going to transfer. But through the writer, I can specify exactly what elements I want to be written out. I can even specify the delimiter. So all these valuable features that you get, all I have to do is use an existing configuration. Similarly for the processor, oh, by the way, you can see it takes in a build entry. And then we're going to look at our item processor. It takes in a bill entry, writes out a result of a bill entry. In this case, I'm just taking a look at that bill entry, and I'm just doing some basic math and setting a bill amount and setting the total amount. Really simple. The reader, similarly, is going to look at a data source. Remember, we're pulling in from our data lake now. We're going to give it a little name called bill entry reader. And then we have this long query where I'm using in to go acquire all the data from the tables so that I can get a single bill entry record. And then I have a bill mapper so that I can map that row. So that's right here. So I can put in the data from the database and put that into the bill entry. And that's it. So I have, what do I have? I have 1, 2 builders. I have a processor. I declare that I have a job with a single step, and I'm done, right? So pretty straight up. I'm going to go ahead and go up to terminal. I'm going to do yet a Maven clean package, or not package, install Glenn. There we go, we're going to install that. And we're going to go back to Dataflow as that's building. Now I'm going to try to remember if I actually remember to clean this stuff up. So I'm going to go back to my applications. I'm going to look to see if I look at our tasks. Remember, we have sources, processor, sinks for our streams, and then we have tasks. So what I want to do is I want to tell Dataflow that it has a bill run task that I just wrote. I think that I actually remember to delete it. Yay! So now you can actually still see a real registration. We're going to do a bill run. And it's, again, a task. And we're going to pull it in from Maven. Again, this can be Maven, Docker, HTTP, or file location. It's wherever you put your jars or your Docker files. And we're going to say maven.io. What did I do here? There we go. .spring, and we're going to do bill run. And we see that I've declared that bill run. We're going to zoom in that so you can see it a little better. We're going to import that. And then we can go and see that I've actually registered that bill run. It wasn't there before. Yay. And now we'll go to tasks. And now I want to create a task definition. In this task definition, I want to take the bill run that I just created, built, and registered. And I want to put that there. But then I've already registered my customer report. So after the bill run has successfully run, I want to run the best customer report. Then I want to terminate. I'm going to create a task. We're going to call it bill run. Well, let's just call it workflow, bill workflow. If I can type. See, that's the reason I copy and paste during demos. Trust me, it's not pretty. And we see that we have our bill workflow, and you can see that it creates these two elements. We can now launch it. And launch. And again, like we had with Stream, I can specify additional properties that I want. In this case, I want to use the defaults. And we can go with the task execution, and we can see that Spring Cloud Task is now reporting back to one location that Spring Cloud Dataflow can monitor, and we can track the execution of this bill workflow. We see that now it's running and has already finished running the bill run. It's kicked off, and now it's running the best customer report. We see that it is completed. And we can wait another 10 seconds, and we can see that the bill run is completed successfully. I can then further down go into the jobs, and we can look at the generate best customer report. And we can see that it had one step in it that had two reads, because in this case we had just two particular users that actually had usage, and it did one write. Or sorry, in this case it was two reads. Yep, that was right. So, and there was only one write because this is best customer report. Basically, the best customer report said, hey, if you've spent more than like $40, I know, cheap cell phone plan, you're considered a best customer. In that case, we can actually see that it ran successfully. We can go back to the job executions and look at the bill run job. And again, we see that it read two customers that actually had data, did two writes, and it did one commit. So we can actually zoom in and see that right there. You can even go into additional detail and be able to see all the commit counts, durations, and get all sorts of good data on that. With that being said, let's take a look. We can see now that I can go to this cat temp. You can see where I cleaned it up before. Bill run, results. And we can see that Jane Doe and John Doe were the two customers. We see Jane spent $21, John spent $100. So if we go with that, we can be able to see the cat temp best customer report. And we see that John was the customer because he spent $100. Jane was actually very hardy and spent her money better, probably. So with that being said, let's go back. Now, I'm going to pull a professor thing. Did your professors ever show you the long way how to do something, and then after they showed you the long way how to do something, they showed you the short way to do it because they wanted you to learn how to do it? Nods from the audience, thank you. Well, guess what? Remember that code that I showed you that said, hey, this is how you have to do your builder, here's how you have to do your reader, your writer, and by the way, here you have to set up the job in the step. What if I wanted to have a single step job where all I had to write was the processor, but the reader and writer was done nothing than, as you can see here, just having the properties there. What if what if I had all I had to do was write the processor, but I could configure the reader and writer through properties, set the job and step configurations through what properties? What if I could do that? Spring Cloud Task offers a feature called Spring Cloud Starter Single Step Batch Job. It's available in the docs. And if you utilize that and put that as a dependency in your POM file, then you can set up and use Kafka reader writers, AMQP reader writers, flat-file reader writers, JDBC reader writers, and you can mix and match those as you see fit, and the only code you have to write is what? The item processor. Great time saver. So I've had to pull my professor moment right there. So, and we're finally getting to the home stretch, folks. Don't give up on me yet. It's going to get even more fun. So we're going to go take a trip to Query Bay. So what are we talking about with Query Bay? So we've already gone from Mainframeville. We've extracted its data from its existing data mountains and put it in a data lake, which we can take advantage of, if you will, in our cloud platform now. Now the data is available. We've migrated a couple of simple applications from the mainframe and moved them into what? Into our cloud platform. Or you could think of it as we moved services out of our monolith, our existing old monolith, and created new services that can do that for us outside, using this new data in a data lake. But now we want to make this data in this lake even more accessible, right? So how can we do that? Well, one of the things that's happened is that you would say, well, I could create a bunch of RESTful APIs, and through these RESTful APIs, people can, have access to the data. But we're wanting to add more features to that. And one of the projects that's been out there, I like the quote here I pulled, but it says it's relatively new. But GraphQL has been out there a while, and what GraphQL does is it allows you, instead of heading at various REST endpoints or getting more data than you like, it allows you to hit off of one individual endpoint and be able to ask it questions, query it, if you will, to get the data you want versus being told, before, instead of getting all this data back. And from that same endpoint, be able to manipulate that data, or if you will, mutate that data. And so it's kind of been like this new way, or I say new-ish way, in order to access an API without having to strictly use REST. REST is great, it does good, but maybe something else is a little bit better. So how can we take advantage of that? So we can look at like GraphQL, and instead of me hitting off an endpoint, in this case, I could take advantage and be able to do for example, for users, I can execute a query saying I want to see the first 10 users, but I want to see the ID and the plan ID. I don't want anything else. And the GraphQL should be able to return exactly what we see here, plan ID and the user ID. But I can hit that same endpoint and change the query a little bit and say I want to see the first name and last name. And again, the data that's returned is what? John Doe, Jane Doe, and Pat Doe. But hitting that same endpoint, I can also mutate that data. I can alter the data. And in this case, I want to create a user. And I can say last name Joe, first name Ruby, and then I want to specify the plan ID. But then I want it to hand me some results back. I want the ID that you created for the user ID. So in this case, I want you to hand me back user ID 1162. So when I'm looking at the GraphQL, what I have the ability to do is to go in and say, how does this look? What do I need to build it? Well, of course, you see the foundation at the bottom is Spring Boot, right? But the other thing is, it's not only Spring Boot, but it's also, we can take advantage of like Spring Data in JPA to be able to create our repositories and our entities and use that to declare the data model that we want to use. But then we want to be able to make it to GraphQL. We want to declare what queries we want to have, what mutations we want to have. And then finally, we want to have something called a GraphQLS configuration that says this is how I want it configured when the user requests it. This is how I want it to look. So we're going to go take yet one more quick demo. And again, I cheated. And we're just going to do a code walkthrough. And so we're going to go to that cell phone GraphQL. And what we're going to do, let's take a look, and we're going to start, the first thing is first. We're going to just take a look at our entities, something we know. If you've used Spring Data before or JPA, this is all existing stuff. You can see I have a plan. You can see where I have all my plan enumerated and annotated the way I want it to be. Users, again, same thing. Well, come on. There you go. Well, or not. There we go. And in this case, same thing. So nothing really new there. Then you'll see where I have a user service. Again, just something that allows me to hit, okay, of course, we have our user repository. Nothing new there. Spring Data straight up. Again, our plan repository, same thing. Nothing really special there. So a lot of boring stuff, Glenn. I'm not seeing the goodness here. Well, it's getting better. So we have our user service where we're hitting off our repository and handing back user information, getting our users, creating a user, all that good stuff, right? Plan, similarly, where I can create a plan, get all plans, get a plan. But that's nothing new. We've always wrote our services. We've already written, so you can see there's just this commonality, this flow, stuff we're used to. Where does the GraphQL kick in? Well, the GraphQL kicks in here. I can now go in and create a query, and I say, here's my GraphQL resolver. So now I can specify what queries do I want to have. I want to have a get users, I want to have a get user, I want to have a get plans, I want to have a get plan. And you see I'm just hitting off my services, right? So nothing really that difficult there. Then the other thing is that I want to have my mutations. Now in this case I broke my mutations into 2 mutations, that's okay. But you see again, we implement the GraphQL mutation resolver. Oh my goodness, what I do? Wow, far out. Okay, I didn't know you could do that. In that case, we create, and again we create our user, and then also our plan mutation. But you see, we're not doing anything spectacular here. It's not that difficult. We create a plan mutation, we create our implements our GraphQL mutation. So you see, create our entities, create our repositories, create our services, we add a query, right? And we also add our mutation for our GraphQL. And then there's only one other thing we need to do. And that's to kind of structure and tell GraphQL how we want to return the data. Tell it we have a plan, tell it we have a user, tell it that we have these endpoints here that we can request a count. We can request an individual user, plan, same thing for count, return a certain number of plans, return a plan ID, and then our user right here where we can pass in, mutation. We can go into mutation and we have our create user and create plan. So I'm going to go ahead and kick this off here. It should run. Come on, IntelliJ. You can do it. Hey, there we go. And we can see that it is now waiting at port 8088, or port 8080, sorry. I'm thinking of something else. And I want to hit a couple of curl requests off of that. So what would that look like? So I'm going to cheat yet again. And I'm going to go back to that first curl command that we had, right? Or the first request that you saw. And it should be right here. And I'm going to make a curl request. Again, notice this query, nothing spectacular here. And I'm going to ask for ID, plan ID. And we can see that, what did we get? We got, whoop. Oh, messed something up there. Whoop, there we go. Let me hit that again. Boop, there we go. And we can see that we got our plan ID and our ID, and we hit off what? One endpoint. Let's hit off that same endpoint again. And what we're going to do is we're going to request first name, last name. Well, if I hit the right app, that would be great. There we go. And we're going to hit that. And again, same query, but I'm asking first name, last name. And we see that we get exactly that. So we're starting to see the advantages of GraphQL. And then we can do this one where I'm hitting off the plan table. And we'll just give a little bit more room there. And we see that we get the plans. So what we were able to do in a few lines of code was to allow people or allow users to have access to our data and be able to query that data, and doing that off the endpoint and getting what they need as they need it in the quantity they need it, instead of hitting off of RESTful endpoints to be able to do that. So it's a really kind of nice, sweet API change there. With that being said, we are going to go back to slideshow. And we're going to now talk about application size. So one of the things that we're also seeing is our users saying is like, okay, I'm moving off of a monolith that's existing on our current infrastructure. When I move to the cloud, I want to make sure that my cloud costs remain as low as possible. And I also want to help out the environment. I want to reduce the energy requirements for how much processors are, I want to help the environment, reducing the energy cost, right? So what are the two ways that we can do that? One, we can run our apps to be a little bit more efficient. The other is we can reduce the memory, right? How much memory there is. So you've probably heard this term a lot before, and one of them is basically GraalVM, right? So the GraalVM is an open JDK, which is cool. It's very efficient, but they also include, at a little cost, a native compiler. And what this native compiler does is it basically takes a look at your Java code and then statically compiles it into native code. The goal will be is that when it does this, it reduces the amount of memory by a very large factor, like a kind of an out-of-the-box Spring Boot app just is like 150 meg. Again, you're not tuning it, you're not adding all the properties to set the size, but just out of the box. Well, if you were to take that same small basic app and you were to natively compile it, the native compile version will be like something, instead of like 50 meg, we're talking, or 150 meg, like what, 30 meg, 15 meg, something really small. Also, if you're into writing functions, it decreases the start time without having a pre-warmed up JVM from seconds to less than 1/10 of a second. So that's its ultimate wonderful thing. It does, or ultimate goal. The problem that you have with that is when it does the static compilation, it's really aggressive. And sometimes it tosses out stuff that you want to keep. But it says, we realize that. So it gives you this configuration that you can add at compilation time that says, please keep this, and this in there. Well, that can take, what, time. So why would we want to save time up front with all these wonderful tools of Spring Cloud Stream, Spring Batch, Spring GraphQL? How can we save time if we're going to just lose it with this compilation process? That's where we have a new project in Spring. It's called Spring Native. It's experimental. And basically what it does is it looks at your Spring-based application and creates that configuration for you so you don't have to write it. So you're pretty much ready to rock out of the box for your foundation Spring applications or Spring Boot applications. The good news is you're saying, okay, is this another dependency I need to add? And if you wait till Spring 2.6 to come out, it will be included with it. And that means it's going to be available in the next Spring Boot, or say the next Spring Boot 3.0 release. So you're going to get this when those are provided, but you're like, I want to play with it now. Can I? Yes. When you go to the Spring, start.spring.io, Josh's second favorite place on the internet, you can actually go and include the Spring Native and your dependencies, and it will set you up. And when you do your build, if you're doing Maven, it's Maven -p native, and you will be able to, it will compile your code, but also do the native compilation for you. So what we covered today, we have covered, I may have an existing application, if you will, a monolith, not this small, maybe a bit bigger, and what we can do is we can extract services out using the Strangler pattern. Or if I have mainframe, I can migrate these mainframe apps off. But in order to do that, I need to have the data that's being currently updated in the mainframe or in that monolith and have it at a location that it's at the ready. I then can migrate my services off using Spring Boot. If you're using, you certainly can utilize, again, the Debezium to get that data off. But once that data is off, you can begin writing applications to implement against it. But you can also provide an API service using GraphQL to be able to retrieve and get that data for whatever new services you want to add. And then when I write my apps, I can take advantage of Spring Native to shrink down the app into something that's smaller to save not only cost, but help our environment out. If you're interested in any of bits of this or any parts of it, the presentation is available on my GitHub repo. And if you're interested in any of the samples, they're also on that same repo. With that, folks, I do appreciate your time. Thank you so much for attending. Whoop, almost off that. Oh, one more thing. A friend of mine from Visa, they're opening up a new Visa office here in Atlanta, and they're doing green pasture development. If you're interested in doing some green pasture in an office, they're really brilliant, building from ground up. I think through the meetup you can leave me a message, and I will send you his contact, and you can reach out to him, and he'll tell you all the good stuff. With that, we're good.